Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students studying the quadratic relations part of the course. In this video, we're going to learn how to do something called completing the square. Now, completing the square is the informal name for the process of converting from standard form to vertex form. So let's look a little deeper about standard form and vertex form. Standard form looks like this. It's probably the nicest to look at, but the least useful of all the forms of a quadratic relation. All we know if we have standard form is the a value, which tells us the shape of the parabola and if it opens up or down. And the other piece of information is the c value, which tells us where the y-intercept is. That's great information, but it's not very useful in a word problem or if we're trying to draw a graph. Instead, we much prefer vertex form. So here's vertex form, and again, it tells us the a value, that's the shape, and the if it goes up or down, but it also gives us h and k. In other words, it gives us directly the vertex. And with the vertex, we can do all sorts of things, like draw a really great graph and answer questions about maximums and minimums and so on. So it's important to us, as we learn this unit, that we can convert from standard form into vertex form. So how do we do that? Well, again, the process is called completing the square. But before we learn the process, we need to look a little closer at vertex form, and more specifically, this right here. So here's vertex form. And that part I just looked at, x minus h squared, is something we call a binomial squared. And obviously, without this, we wouldn't have a quadratic. We wouldn't have x squared, and we wouldn't have anything that was related to this unit. So it's really this binomial squared that's the most important part of the vertex form. And it's the part we need to focus on to learn how to complete the square. So let's start by looking at some binomial squares. And we'll practice doing something we've done a number of times already. Let's actually expand this bracket. So one method is you could simply do exactly what that squared tells you to do. Anything squared means multiply the base times itself. So my base is x plus 3 multiplied by x plus 3. And now we'll do FOIL, firsts, outsides, insides, and lasts. And then we'll collect like terms to get x squared plus 6x plus 9. So I expanded this binomial and I got this trinomial. Let's do it again. Only this time we'll use the method that if you're one of my students, you're probably more familiar with, because I like to do things mentally and I like to take shortcuts. When I square a binomial, what I do is I double the product. Sorry, I square the first, double the product, and square the last. So you've heard me say that over and over again. Square the first, double the product, square the last. So square the first, double the product. So double 11 times x, and square the last. And then doubling the product, so 2 times 11x would give me 22x. So it's a nice shortcut you can use to squaring a binomial. Again, I squared the first, I doubled the product of the two terms, and I squared the last. So again, squaring a binomial gave me a trinomial that looks like this. Let's do it one more time, and this time we'll use one step, square the first, double the product, negative 9 times x, doubled, is negative 18 times x, and square the last. So all of these binomials gave us trinomials that look like this, and each of these methods you're welcome to use whichever one you choose, as long as you do it, as I like to say, correctly and quickly every time. So we know that when you expand or square this binomial, you get a trinomial that looks like this. And of course, a trinomial that looks like this is familiar to us because it's a perfect square trinomial. And we studied these when we studied the unit on factoring. So squaring a binomial always creates a perfect square trinomial. And what's also important, and in fact more important to us right now, is that a perfect square trinomial factors into a binomial squared. So expands, factors, we know that they're just opposite operations. So if I have a perfect square trinomial, I can factor it into a binomial squared. And that's important to us as we learn this process. So let's go ahead and look at two examples. So I'm going to use green to represent my brain. There's my brain. Is this a trinomial squared? So is this a perfect square trinomial? Is there a number that is the square root of 16 and is half of 8? Well, yes, there is. We know that the number 4 is both the square root of 16 and half of 8. So that's a perfect squared trinomial, and it factors into this. If this wasn't a 16, if it was a 17, a 12, a 28, a negative 16, this wouldn't work. But because it happens to be 8 and 16, those are the right numbers. So let's do the same thing here. And again, let's use our brain bubble. Is this a perfect square trinomial? Is there a number that is the square root of 225 and that's also half of 30? Well, half of 30 is 15. Well, half of negative 30 is negative 15. So quick check, is 15 squared 225? Yep. So that's also a perfect square trinomial, so it factored into this binomial squared. So good, we can expand and we can factor. But what's most important to us, as we are almost ready to learn how to complete the square, is we actually have to be able to create a perfect square trinomial. And actually not just create, but we have to be able to create and factor a perfect square trinomial. Because part of actually creating a perfect square trinomial is almost like factoring it. And here's my example over here. We just saw this question, so let's focus in on it. That this number 4, again, it's half of 8, and 4 squared is 16. So instead of thinking half of 8 and the square root, what I prefer to do is I prefer to think of this as half of 8 is 4, and 4 squared is 16. And that's why I like to talk about both creating and factoring at the same time, because that number 4 is important. So let's go ahead and see if we can create a perfect square trinomial. In other words, give me a number to put here so that this expression is a perfect square trinomial. So in order to do that, we're going to factor. What's half of positive 10? Positive 5. Square that, and I get 25. This is a perfect square trinomial, and it factors into this binomial squared. So let's do some more examples. What number do I have to put here? And it's always going to be positive because no matter what, it's a perfect square. So again, I'm going to create that number by thinking about factoring. Half of 16 is 8. 8 squared is 64. Perfect square trinomial, binomial squared. Here's another example. So again, we're going to create the perfect square trinomial by factoring. Half of negative 20, negative 10 squared. There's my perfect square trinomial. One more example. Again, I'm going to take half of 5. Now, no decimals, please. Half of 5 is 5 over 2. And then I'm going to square that. 5 squared over 2 squared. So there's my perfect square trinomial. See, this is one of those examples where it's far easier to not use a calculator. 5 squared is 25, 2 squared is 4. I wouldn't want to see decimals there. So now that we know how to create a perfect square trinomial, I want to draw your attention to something. Each of these examples that we've been looking at has an a value of 1. And in the bracket, that's just an x. There's no coefficient other than 1. And that's important because we need that to be true in order to do the process called completing the square. And you'll see why in a couple of examples why that must be. So here we go. We're finally going to complete the square. Yay. So in order to complete the square, so we're going to write in vertex form. Again, this is what vertex form looks like. And vertex form has the most important piece, this binomial squared. And now we know that a binomial squared means we need to create a perfect square trinomial. Because if we have a perfect square trinomial, we can factor it and it'll look like this. So here's the equation, y equals x squared plus 12x plus 15. And our job is to create a perfect square trinomial. So this plus 15 It's not really part of what I'm about to do because I'm going to take these two terms, just like we were doing on this last page, and I'm going to create a perfect square trinomial. So in other words, I'm going to put something here that gives me a perfect square trinomial. So I can't ignore this plus 15. I'm just going to write it over on the side to remind myself it's still there, but I need to do something else. So let's think about it. What am I going to put here? Green brain, green brain. So normally I would say take half of 12. Half of 12 is 6. 6 squared, aha. Now I know, thank you brain, I know that the number I want is the number 36. So I'm going to add 36. And there's my perfect square trinomial. But there's a problem. You can't just add 36 to an equation without fundamentally changing the equation. So how do I do? What do I do? I know I need to add 36 because I need a perfect square trinomial. So what I'm going to do is I'm going to compensate for adding 36 by subtracting 36. That seems fair, doesn't it? 36 minus 36 is 0. You're allowed to add 0 whenever you want. That's not a problem. And now I have my perfect square trinomial. And over here, I have things that I can deal with later. So let's go ahead and factor that perfect square trinomial. And remember, we already did this in our head, right? That step when we took half of 12 and got 6 was already that factoring step. So there's my perfect square trinomial factored into a binomial square. And now I have negative 36 plus 15. Well, that's just collecting like terms. Negative 36 plus 15 is just negative 24. So there's my original expression rewritten in vertex form. And we could even say, now we know that a equals 1, and the vertex is at negative 6, negative 24. Great, we could graph it, we could answer questions. Let's do another example. So again, I want to rewrite this into vertex form. So these two terms here are going to be used to create a perfect square trinomial. And this negative 112, let's just move it over here. We'll deal with it later. So brain, time for you. Hello, brain. Ooh, ugly brain. Okay, what number do I have to add to create a perfect square trinomial? So I need to take half of negative 24. Half of negative 24 is negative 12. And if I square 12, what do I get? I get 144. So if I add 124, I've created a perfect square trinomial. But of course, you can't just add 144 unless you also subtract 144. And that gives me a perfect square trinomial and stuff to deal with later. So go ahead and factor. And again, if this is your brain, you've already factored it. Half of negative 24 is negative 12. Negative 144 minus 112, we can do that. That's negative 256. So that was quick. We now know that a equals 1, and the vertex is at 12, negative 256. Let's do another example. These two terms are going to be used to create a perfect square trinomial, and this term is just going to be moved out of the way. So x squared minus 5x, and we're moving the 14 out of the way. So again, brain, what number do I need to add to create a perfect square trinomial? So take half of negative 5. Half of negative 5 is negative 5 over 2. Square that, and I get 5 squared over 2 squared, which is 25 over 4. So we're going to add 25 over 4, but again, I can't add it unless I also subtract it. So here's my perfect square trinomial, and here's the stuff I'll deal with later. So go ahead and factor. And in your brain, you've already factored. There it is, x minus 5 over 2 squared. Now here, negative 25 over 4 plus 14, well, to add, I need a common denominator. So 14 over 1 is equivalent to 56 over 4. So now that I have a common denominator, I can finish. And I have negative 31 over 4. So there I have it in vertex form. A equals 1, and the vertex is at 5 over 2, negative 31 over 4. Nice. Now, all of the original questions I've given you in the last 3 questions have all been simple trinomials with a equal 1. But obviously, not all trinomials look like that. Some of them look like this with a equals something else. So we also have to complete the square here. How do we do that? Well, we need to somehow separate that coefficient from x squared, because we know how to complete the square if it's just x squared, and we can't do all the steps we need to do with that coefficient. So what we're going to do is something called partial factoring. So I'm going to factor that too. Now, I'm not thinking about factoring like in the last unit. I'm not trying to common factor. I'm not trying to um, factor everything. All I need to do is whatever this number is, I have no choice. I have to factor it out because that'll give me x squared, and I love x squared. Now, I also, since I'm in the factoring mode, the other piece of the puzzle I need to factor, of course, is this negative 8x, because that's part of the completing the square process. So factor a 2 out of this term as well. That gives me negative 4x. Now, I'm not going to worry about factoring 11, because 11, we know that that just does nothing until the end anyway. So why bother factoring it? So this is why we call it partially factoring, because I've only factored part of this expression. I factored the 2 most important terms, and this plus 11 didn't get factored. So that's what these brackets really are important for right now, is they show me this stuff in the bracket really is supposed to be multiplied by 2. 2 times x squared, 2 times negative 4. The plus 11 doesn't get multiplied by 2. That's why it's not in the bracket. Okay? So, looking at what we have, x squared minus 4, this is now where I want to do that step again. Let's create a perfect square trinomial. So don't worry for now. Oops, red pen, don't want that. Don't worry for now about this 2. And definitely don't worry about this 11. Just worry about what number should I write here to create a perfect square trinomial. So we've already seen this. Half of negative 4 is negative 2. Negative 2 squared is 4. And again, I know you're saying this already. If you add 4, you also have to subtract 4. So what we have is our perfect square trinomial right here. Beautiful. We'll factor that in a minute. But we also have this. Now, I don't want that in the bracket because I need to factor what's in the bracket to create a binomial squared. So this needs to come out of the bracket. But remember, why is it in the bracket at all? It's in the bracket to remind us to multiply by 2. So when I take this out of the bracket, I'm multiplying it by 2. So really, that's the number negative 8. So this is what my next step looks like. I haven't yet touched my perfect square trinomial. It's waiting for me to factor it. I'll do that soon. But this negative 4 term got moved out of the bracket. And when it got moved out of the bracket came into effect. Multiply by 2, and there's good old plus 11 waiting. We're just waiting. You know, he's a nice guy. So now, finally, yay, perfect square trinomial. Let's factor. So there's the 2, factoring this. Again, half of negative 4. There it is. And out here, negative 8 plus 11, well, that's just plus 3. There I have vertex form, where a equals 2. And the vertex of this parabola would be at positive 2, comma 3. So let's try another example. So the first thing I need to do is look at this negative 3. I have no choice. So I must factor negative 3 out of the first 2 terms. That plus 56, he's just going to be here and wait patiently. So factor negative 3. So that's just x squared, good. Negative 12x divided by negative 3. There we go. So again, factoring is like doing division. And again, you should always check if I were to multiply, would I go back to what I had? Yes, I would. So now that we've factored, now let's complete the square. Write a number here that gives me a perfect square trinomial. Half of 4 is 2. 2 squared again is 4. And if you add 4, make sure you subtract 4, and all of this is in a bracket. The only thing not in the bracket is that 56. So what do we have? This is beautiful because it's a perfect square trinomial. This needs to move out of the bracket. It needs to let the perfect square trinomial be alone. So when I move it out of the bracket, what do I need to remember? Aha, I need to remember that the bracket says multiply by -3. So that's what I'm going to do next. So I still have a bracket because I still have those three things that make the perfect square trinomial. So -3 is still going to affect these guys, but that -4 multiplied by -3 becomes positive 12. And plus 56, he's just patient and waiting. So now, yay, I can factor. So half of 4 is 2. 12 plus 56 is 68. And there I have, in vertex form, this equation where a equals -3 and the vertex is at -2 and 68. So let's do one more example. So this time, the number I need to factor is the number -1. Yes, even though it's not as complicated as 2 or 3, you still have to factor that -1. So that's going to give me x squared plus 7x. Leave some space, and there's plus 13. So I factored. So again, let me erase here. I looked at the first two terms. Notice that I have a -1 on the x squared. So I factored -1. So I got x squared, and now I have positive 7x because -7 divided by -1 is positive 7. So now take half of this number and square it. So let me use my brain this time. Half of 7 is 7 over 2. 7 over 2 squared, well, 7 squared is 49. 2 squared is 4. So that's the number I have to add to create a perfect square trinomial. And of course, if I add it, I also have to subtract it. So here's my perfect square trinomial. And here's the thing I need to get rid of by moving it out of the bracket. And remember, that bracket says multiply by -1. So that's exactly what I'm going to do in my next step. I'm going to take that -49 over 4, multiply by -1. So now it's outside of the bracket. So factor, collect like terms. Oops. So we already know how this factors because we took half of 7 already. And that's how we got 49 over 4. So here, I need to get a common denominator. So 13 over 1 is equivalent to 52 over 4. And then finally, in final vertex form, I have 101 over 4. So what do we know about this parabola? A equals -1. And the vertex is at -7 over 2 and positive 101 over 4. So there you go. That's completing the square. Make sure you practice because even if it looks easy, nothing's easy if you haven't practiced it. So go do some math, and I'll see you at school.